Hi, boys and girls. Today we're going to be doing lesson 9.2, equations and tables. In the last lesson, lesson 9.1, we discovered what an independent and a dependent variable is. The independent variable, comes first, and it is usually applied with a constant of some kind. And it has to happen because the dependent variable is dependent on it. So we're going to take this to the next level, and we're going to translate between equations and tables today. That's our objective, okay? So to start with, when an equation describes the relationship between two quantities, the variable x often represents the independent variable and y often represents the dependent variable, okay? Last time, on our last lesson, we used a letter that just kind of went with the problem. Today, we're going to use x and y. X is going to be my independent, Y is going to be my dependent. A value of the independent variable is called the input. See the word in? In. Get the independent variable? Input. That should help you remember. And the value of the dependent variable is called the output. So let's take a look at this diagram right here. Inside the box, okay, you have an equation. This is my independent variable, and this is my dependent variable. So when I put something into my equation, the output, okay, will be a result. So if I say that x is equal to 2, then y is going to be equal to 5. If I say now that x is equal to 4, then y is going to be equal to 7. All right? So this is important today. You're going to have an input, and whatever the input is put into the equation, it will create a different output. All right, so let's go to your book and let's take a look at some examples. Pull this off to the side. Here is your unlock the problem for today. So let's take a look here. I'm gonna pull this up as far as I can. All right, a skating rink charges $3 for each hour. See the word each? Probably gonna be doing multiplying, don't you think? Of skating, plus $1.75 to rent the skates. We are going to write an equation for the relationship. See the word relationship here? That gives the total cost in dollars for skating X hours. Then make a table that shows the cost of skating 1, 2, and 3, and 4 hours. Okay? So we're going to write an equation right now for the relationship, okay? That's between X, okay, and Y. I want to know what's happening from the independent variable to the dependent variable. So the total cost is going to be my dependent variable. This is going to be y. Oops. Is equal to 3. This is what it costs each hour, right? This is my constant. We talked about that. $3 for each means to multiply. You see your dot there. Per hour, this is going to be x. Instead of an h, let's put an x here. Plus the cost of the skates. This is the cost of the skates. Okay? So my equation is going to be, kind of made a mess there. It's going to be y is equal to 3x plus $1.75. Okay? All right, it's supposed to be a sign. Oh, okay. All right, so now I'm going to make a table. And this is the way my table looks. One side is my independent variable. I'm going to put the rule right here. The rule is the actual equation, guys. That's just the equation you just created. The output, that is my dependent. So this is independent, abbreviate, and this is going to be my dependent, okay? So right here are the number values that represent the independent variable that in this case is going to change, okay? So if I just go skating for 1 hour, then it's going to be 3 times 1, which is 3, plus $1.75, which is $4.75. If I decide to skate for 2 hours, I'm going to have 3, I'll write the time sign, times 2 plus $1.75, okay? So that's going to be 6 plus 175 is $7.75. Okay, let's change that independent variable another time. It's going to be 3 times 3 this time, plus $1.75. We're still applying the same equation. This is now 9 plus $1.75 makes this $10.75. I'll make it neater if I can. Now, what if I change it one more time and I make it worth 4? Okay, times, I hate to use the times sign, but times, goodness, 4 plus $1.75. My screen is not cooperating today. So that's 12 now plus $1.75, so that's $13.75. Okay? So the dependent variable changed every time I changed the independent variable. Does that make sense? I hope this is making sense to you. We're working with independent and dependent variables. All right, let's take a look at the next page on page 498. We have another story problem here. This time we have Jamal, okay? Jamal downloads songs for his MP3 player. The table shows how much time it takes for him to download a song depending on the song's file size. Write an equation, okay? We're still writing that equation for the relationship shown in the table. Then use the equation to find how many seconds it takes Jamal to download a song with a file size of 7 megabytes. All right. Okay, so let's take a look at what we've got here. That's 7 megabytes. Okay, we're going to look for a pattern between the file sizes and the download times. Okay, I hope this question makes sense to you. So, what do we have here? We have the file size is going to be my independent variable. Whatever the size is of my independent variable will change the time. Okay? So the download time, which is y, is 12, okay, multiplied by the file size, which is going to be x. Okay? So I'm going to have the equation y is equal to 12x. Okay? Or 12 times x. So I have a table here. My download time, download file size, if it were 4, I would take it times 12 and it'd be a 48, and so forth. If the file size were a 5, it'd be a 60 because 5 times 12 is 60. 6 times 12 is 72. I want to figure out, they're asking me, they're saying, find out for me, what if it were 7? They left this blank because they want you to do that. Okay? They did 8 for you. So you can see what's going on. So if my file size was 7 megabytes, they're giving me a substitution. Do you remember that word substitution? That means we're going to substitute for that x or for that independent value. Okay? They're telling me that the independent value is going to be a 7. So if I do that, 12 times 7, look on your times chart real quick. 12 times 7 is 84. So I can solve for 7. I can replace that right here as an 84. Okay? So it's for a 7 megabyte song, it will literally take him 84 seconds to download his song. All right, boys and girls, I hope you're getting this. The X is the independent, the Y is the dependent. So let's take a look at the share and show. Let's take the story problem out for a little bit today. We're just going to take an equation that's already written for you here. Something simple like x plus 3. Okay, my rule is going to be x plus 3 right here. Okay, my input is right here. This is my x, and it's going to create the y. So if I put a 6 in for the x, like they have done here in the example, we're going to have 6 plus 3 is 9. All right, what if it's 8? I put an 8 in for the x, and then I have 11. Now, if I put a 10 in here for the x, I'm replacing it. Remember, I'm just substituting. then I end up with 13. Now what I want you to notice is you have a pattern here. It's going up by 2. When the x went up by 2, the y went up by 2. That's what happens when we add. Everything in math is about a pattern, pretty much. When we're working with equations with an input and output, you're going to see a pattern every single time, okay? This time I've got a formula or a rule or an equation, 2x plus 1. What if x is a 4? What if I input 4? So I'm going to say 2 times 4 plus 1. Let's do the times first. That's 8 plus 1 is 9. So my output would be 9. Now what if x is 7? So it's going to be 2 times 7 plus 1. That's 14 plus 1. That equals 15. All right. What if x is 10? That's 2 times 10 plus 1 is equal to 20 plus 1 is 21. All right, boys and girls. Again, we have a pattern. Each time it goes up by 6. All right. So I'm going to have you go ahead and work on these on your own problems by yourself. Okay. And remember, you're going to write an equation. You've got to kind of figure out what's going on for the relationship. Okay. What if I change my mind? What if I do number 3 with you? And then I'll let you do number 4. So y is my output. Let's just go ahead and do this and make it easy. Let's say y is equal to. Let's start out right away. Now let's analyze. You know that word analyze? Okay. We're going to look at x and we're going to look at y. All right, 8 and 16. How are they related? 9 and 18. Okay. Same relationships happening from x to y. It has to be the same thing. Something's happening to x. Does that make sense? So if I have x on this side, what am I doing? I'm going to be adding, subtracting, multiplying, or dividing. So I could add on 8, right? But if I add 8 to 9, does that make sense? No. So since I'm getting bigger, I must be multiplying. 8 times 2 is 16. So what's 9 times 2? Well, that's 18. So if I take x and I take it times 2, then it works for this particular table. So 10 times 2 would be 20. 11 times 2 is 22. Well, that's a true table. This works. So boys and girls, when you're writing an equation, you're looking for that pattern. This equation is also the pattern, okay? In this case, in the number 4, you're going to see that it's decreasing in size from the independent to the dependent. So you are either going to subtract or you're going to divide, one or the other, if if you are decreasing in size. Okay? So in this case, y is always the answer. Something's happening to x. X is what? Okay? So if this is a 10 and this is a 5, that's exactly half as much. That's 20 and that's exactly half as much. When things are half as much, we're actually dividing by 2. Okay? All right, so half of 40 would be 20, following that rule. All right, boys and girls, changed my mind, did number 3 and 4 with you. Today, you are going to either be writing an equation or you are going to or filling in a table or writing an equation based off of the table. All right, today's objective was to be able to look at how equations are related to tables. All right, boys and girls, happy math.